Hi, so let's discuss inequalities. Now, before we understand what is an inequality, we have to first see what is the difference between an equality and inequality, right? So, equality and inequality. Equality implies is equal to, right? Whereas inequality has four signs: greater than, less than, greater than or equal to, or it's called at least. And the last one is less than or equal to, or it's called at most. Now, these are the letter symbols used in, or the signs used in equality and inequality. What is the difference? When I say x is equal to 4, I'm talking of a definite value of x. X is equal to 4 only. There is no other value for x in this case. Whereas when I'm saying x is greater than 4, I'm talking of a range of values. What is range of values? Any value greater than 4. Be it 5, be it 6 point some decimal, 100, 300 upon 11, which is, let's say, 20 something. Any value above, even it is a 4.001, any value greater than 4 is part of this equation, or in inequality, we always get range of values. So when you're solving inequality, you are solving for the range of values of that variable, be it x, a, y, z, whatever, right? So this has to be pretty clear, the difference between equality and inequality. Now, so visualizing an inequality on a number line, or it's called x-axis, right? So how there is a difference between these two. There is a greater than and there is less than and an equal to sign. So when we are talking about on a number line x greater than 6, we will be using a circle, an empty circle. Whenever we use an empty circle, that means that value is not included, right? When we said x greater than 4 in the previous slide, that means any value except for 4. If you don't want to include that particular value, but you want to start from that value, you put an empty circle. Now, when you want to include that, okay, here a is less than or equal to 8. Okay, if it is less than, it would be like this, but if it is equal to, you make it a solid. You make a solid circle, you are including that value. So that is how you will represent, or it is generally represented, okay, when a sign or when a value is included or when a value is excluded. Now, extremely important, this is the basis of solving all inequalities, right? Effect of addition, subtraction, division, multiplication and division of a constant to inequality. Okay, when you add a constant to both the sides of the inequality, how does the inequality change, right? With these, so we'll see first the addition. When we add, let's say 6 is greater than 4, we know, right? This is true. Now, when you add a constant, a positive constant to both the sides, remember, it can't just be you're adding to one side, right? And this applies. No, you have to add, subtract, multiply, divide of the constant both the sides. 6 plus 2 and 4 plus 2 is 8 greater than 6, right? So here 8 is still greater than 6. When I add 2, it becomes 8, and when I add 2 to 4, it becomes 6. 8 is still greater than 6. So what does that mean? That means that addition of a constant to both sides does not affect the inequality, as you can clearly see. The same if I subtract same constant. 6 greater than 4, true. If I subtract, 6 minus 2 is 4 and 4 minus 2 is 2. 4 is still greater than 2. So subtracting a constant on both sides of inequality does not affect the inequality. Okay. So addition and subtraction does not change the inequality. Now let's come to multiplication. 6 greater than 4. If I multiply by positive constant, which is 2, 6 into 2, 12, 4 into 2, 8, 12 is still greater than 8, the inequality does not change. Does not affect means does not change, right? So you can make a note of all of this. Now let's see, if I multiply by negative, this is true, 6 greater than 4. If I multiply by negative value, it becomes negative 12 and negative 8. So here we know that negative 12 is less than negative 8. So what happens here is the inequality reverses. Okay, this is important. So whenever you are multiplying both sides by a negative value, you reverse the inequality. You do it manually, right? It does not reverse on its own. You have to reverse the sign. Same for division. If we divide by a positive constant, right? This is true, 6 upon 2, 3 and 4 upon 2, 3. This does not affect, right? But if you divide by negative, negative 3 and negative 2, negative 3 is less than negative 2. So multiplying or dividing by a negative constant, right, will reverse the inequality. And in any other cases, you can directly, let's say, do any operations. For example, if it is like this, x upon 2 is greater than 1, can I take 2 to the other side? Yes. And do I have to change anything? No, because I am taking a positive value, right? Or let's say I'm multiplying by 2 on both sides. Since it is positive, I need not change the inequality, right? This is important. Whenever you are shifting to the other side, just be careful if you're shifting a negative or a positive for division or multiplication. We saw addition and subtraction, it doesn't matter anyways. Now, if let's say 2x is greater than 6, so to get 2, you divide both sides by a positive value. So when I divide by positive value, I get x greater than 3. I need not change the inequality. Okay, I need to change only if I'm multiplying or dividing by a negative value. So this is straightforward. Now second one, if negative 2x is greater than 6, to get to x, I need to divide by negative. And we know if I divide by negative, the inequality reverses. So this greater than becomes less than. Rest everything, you solve it normally. 6 upon 2 is negative 3. Negative 2 gets cancelled. So I write x is less than negative 3. Okay. So it's like solving a inequality is solving like a linear equation, right? You divide both sides by negative 2. You'll say x is negative 3. Just that when it becomes inequality, you take care of the sign when you're dividing by negative, right? Even here it's the same. 2x is equal to 6. Divide by 2, x is equal to 3. So this is how inequality can be considered as an linear equation or equal to just taking care of the signs. Now here you have to divide by 2. It's positive, so nothing changes. The inequality still stays the same. So here x is greater than negative 3. The last one, to get to x, you add 2 both sides. And we know that addition or subtraction does not affect the inequality any which ways. This is straightforward. So this is how you can easily solve the inequalities using the rules or remembering how addition, subtraction, multiplication, division affects the inequality. Now, solving inequality Okay, is the same way as that of linear equations. We have just discussed, keeping in mind the effect of multiplication and division by a constant when they are negative. So we'll solve 2-3 questions. So remember, we'll solve it the same way. So we bring 3x to left hand side, all the variables to one side and all the constants to the other side. So you either subtract or you bring 3x to this side and you add 22, addition or subtraction, or you take 22 to the other side, nothing changes. So 10x minus 3x is 7x is less than 22 plus 34. So 7x is less than or equal to 56. Now you divide by 7, positive value, nothing changes. So the solution is x is less than or equal to 8. Straightforward. Yeah, so this is where it might seem a bit tricky, but it is not at all tricky because the values are positive. If they are positive, you can multiply or divide, take them to the other side without changing anything, right? So I can take them to the other side, treat it just like a is equal to sign, right? Especially since they're positive, I don't need to change anything. So 3x plus 9 is greater than 5x minus 5. So I bring 5x to this side and 9 to the other side. So this becomes negative 2x. Positive 9 becomes negative 9. Now to get to x, I'll need to divide both sides by negative 2. What happens? Divide by negative 2, you reverse the sign automatically. Okay. Rest everything stays the same. This is our solution. Okay, when there is positive, you can easily, without any second thoughts, take it to the other side. Okay, this is again solve for x. There are two inequalities. So the way I can solve these questions is try and eliminate the constants first, right? How do I eliminate constant? In the middle part, so I add 7 to everywhere, all the sides. Addition does not change the inequality. This gets cancelled. I have 22 here, 2x here, and 28 here. Now I have to solve for x. What I'll do, I'll divide by 2 on all the sides. Division of positive does not change. So 11 is less than, x is less than 14. This is the solution. Solve for x. Or the question sometimes can ask how many integers satisfy integers x satisfies this equation. If they ask something like that, how many integers? X is greater than 11 but less than 14. So x can take two integers, 12 and 13. So answer would be 2. The questions like this can be framed in a different way, but the solution, the way you will solve, will still be the same. So I hope the basics of inequalities are clear. Having this much clarity of inequalities is good to go. So that's about inequalities. I'll see you guys in the next video. Thank you.